So last class, we looked at how to solve problems which involved compound interest by using a formula as opposed to making a table and calculating a running total after every year. And our formula was this one, F equals P times 1 plus R over N to the power of NT. Sometimes this is A, sometimes this is F, depending on how it's written. And this is helpful for finding the future value of an investment, which is built upon compound interest. Now, we're not always looking for the future value, however. Sometimes we might have a future value in mind, like a goal that we want to earn, and we might want to know how much money that we have to invest in order to make that happen in a particular time at a particular rate of interest. Well, you can probably see that I can rearrange this formula and solve it for P by taking all of this stuff that's on the right-hand side, 1 plus R over N to the NT, dividing both sides by it, so P will be all by itself. And what we'll get is P equals F divided by 1 plus R over N to the power of NT. So this is a formula that will give us the present value, so what we need to invest now, given a future goal of what we want to earn, an amount of time that we want to earn it in, and a particular interest rate. Well, okay, this formula is a little more tricky than the first one, but it's pretty similar. But what if you didn't actually want to solve for future value or present value? So perhaps you might want to solve for an interest rate. For example, I know how much money I have right now. I know how much I want to have in 5 years. Well, what interest rate do I need to make that happen? Now, interest rate is inside this formula, and we have an exponent up here. So we have to do this unwieldy rearranging in order to get rid of this exponent, which is beyond this course, but I've taken the liberty to do it for you. And we get this very ugly formula of n times f over p to the power of 1 over nt subtract 1. And this is an interest rate based on a particular time, compounding period, future value, and present value. But wait, maybe we don't want any of those things. Maybe we know the interest rate, and we know how much money we have right now, and we know how much money we want in the future, and we want to figure out how long it'll take us to do it. Well, that rearranging is definitely outside the course, but that gets us to this formula of t equals ln of f subtract ln of p divided by n times ln of 1 over r over n. Now, there's one thing that all of these formulas have in common, and they're probably described by the word unwieldy. We don't want to use these sorts of formulas to do these complex calculations, but if we were doing mathematics 50 years ago, this is what we'd be doing. We'd be taking these original formulas, we'd be rearranging them to solve for one of these variables, getting one of these perhaps ugly formulas, and then substituting in a bunch of values in order to solve an equation. Thankfully, however, we can now use computers in order to do a lot of this calculation for you. And those calculations and those programs are built into our TIs. So what we're going to look at on the next slide is, instead of using any of these formulas, how we can bypass this entirely and just use an application on our TIs in order to find the final interest rate.